Hello student, myself Professor Ushali Tapde from ICEEM Engineering College. Today we will discuss about the insertion sort. But before that we have to just in 2 minutes revise whatever we have seen till now, that is the different sorting technique like a bubble sort and selection sort. What is the sorting? Sorting is the process of arranging the records either in ascending or descending order. Okay, so in the sorting we have seen about the bubble sort. What is a bubble sort? The bubble sort the given elements by comparing to adjacent element, and if necessary then swap them according to your logic. If you necessary then you can swap them. This is the bubble sort. And in selection sort, what we have to do? In selection sort we have to select the smallest element, the very first smallest element from the given element, and place it at the first position. Then we have to select the second smallest element, place it at the second position. In this way the selection sort will sort the given array. Now the time complexity that is required by both the bubble sort as well as the selection sort is nothing but a O of n square. So in last lecture we have seen about the selection sort, how to write the program for selection sort as well as the advantages and disadvantages of the selection sort. Now in today's lecture we will see what is a insertion sort. In the insertion sort, this sorting technique sort the given list by inserting the element into an existing sorted list. Okay, what the insertion sort do? It select the element from the unsorted list and placed it into the sorted list at their proper position. Insert the element into the sorted list at their proper position. That's why it is called as a insertion sort. This method works on sorted as well as the unsorted list. Okay, because it select the elements from the unsorted list and insert it into the sorted list at their proper position. That's why it is called as the insertion sort. From the given array, the first element is considered as a sorted list and remaining are considered as an unsorted list. That means there is no need we have two separate lists. If the list is given to us, what we have to do? We consider the first element of that list as a sorted, because there are no remaining elements. We are considering only one element, so we consider it is already sorted, and remaining elements we consider as an unsorted list. Now this method finds the insertion position of the current element from the unsorted list in the previously sorted list. That means we need to find the position of the element from the unsorted list and insert that element into our sorted list at their proper position with the help of insertion sort. This insertion position is found by comparing each previous element in a sorted list such that A of j should be greater than A of k. Now what is a j and what is a k? K is nothing but an index of the unsorted list, whereas j is nothing but the index of the sorted list. So what we have to do while finding the insertion position of the element from the unsorted list, we have to check whether A of j, that is the element of our sorted list, is greater than the element of our unsorted list. If the condition is satisfied, we have to compare this thing till we find the proper position of our element into the sorted list. As the element from unsorted list is placed into the sorted list, the unsorted list is reduced, whereas the sorted list get increased. Obviously we consider the first element of our list as a sorted, whereas the remaining element as a unsorted, right? So we are taking one by one element from our unsorted list and place them into their proper position in our sorted list. So as soon as we are placing the elements from the unsorted list into the sorted list, unsorted list becomes reduced, whereas the sorted list get increased. When the elements are placed in the sorted list, all elements from A of j plus 1 to A of k minus 1 are shifted one position right, and then the current element A of k is stored at position A of j plus 1. That means when we are comparing the element whether A of j is greater than A of k, if we found that A of j is greater than A of k, and once we found the position of the element which we want to place into the sorted list, what we have to do? We have to shift all the elements from that position to the one position of right. Okay, we have to shift all the element to the right position by one position. So in this way it will work. The idea of this method is to place on its correct position in a growing sorted list of data. So whenever we want to place the element at their proper position, we need to make the space for that element in the sorted list. So what we have to do, whatever the element that is greater than this element, we have to shift them one position to the right, so that there is a place for placing our element at their proper position in the sorted list. The idea of insertion sort is similar to the idea of sorting the playing cards. Whenever you play the card, what you have to do, you have to consider one first card as a sorted and remaining cards you have to place one by one, like in a ascending order. So the same idea of the insertion sort, you have to make the place for keeping your unsorted elements into the sorted element. It is a simple sorting algorithm which sort the array by shifting elements one by one. How this insertion is done? By shifting element from the sorted list one position ahead to the right side. It has one of the simplest implementation. It is the efficient for smaller data set but very inefficient for the larger set. Obviously, how it will work, it will select the element, then it will compare that element with the sorted list, then it will perform the shifting to to make the place for the element to be inserted into the sorted list, and then it will insert. So in the fourth stage it works. So if your data list is small, then it is a efficient method, but if your data list is too much large, then this method is not efficient for sorting of that larger list. Insertion sort is adaptive, that means it reduces its total number of steps if given a partially sorted list. Hence, it increases its efficiency. As we know that in the bubble sort as well as in the selection sort, even though the elements are sorted, it will perform all the passes. But this is not case in the insertion sort. It is an adaptive technique which reduces the total number of steps if given a partially sorted list, so that it increases the efficiency. So it is better than the selection sort as well as the bubble sort algorithm, as in comparison with the time complexity as well as in comparison with the space complexity. The space complexity required by the insertion sort is less as compared to the bubble sort. Okay. It is stable as it does not change the relative order of elements with equal keys. This is an algorithm for the insertion sort. We have again two loops, one for the comparison and one for shifting the array. For I is equals to 1 to n, we have an array with n number of elements. So we are started with one by one element to check whether that element is at the proper position or not. So first we have to take the element which is at the a of the I position into the key, and we said that now this j is nothing but the position of our index of our sorted list. So we check whether j is greater than 0 and a of j is greater than key. If we found that a of j is greater than key, then what we have to do, we have to take the element from unsorted list into the sorted list by using these logics. So in this way the insertion sort will work. Now here we will take the example, so this idea is clear to you. Here we have a 6 element, so we consider that the first element is our sorted elements and remaining as a unsorted list. So we have to keep one by one element into our sorted list. So we compare, as we can see here insertion sort, we pick up the keys and compares it with the elements ahead it and puts the key in the right place. Okay, so 5 has nothing before it, so that means 5 is at their proper place. Now then we have to move to the next number, that is a 1. Now before 1 there is a 5 which is out of order, so we need to shift the 5 at the 1th position and 1 at the 5th position. Similarly for the 6, now here 6 is greater than the 5, so it at their proper position. Then we have to move to the 2. 2 is smaller than 5 and 6. 2 is smaller than 5 and 6 but greater than 1. So we need to insert 2 at after 1 but before 5 and 6. So in this way your insertion sort will work. So we take one example and we'll see how the exactly insertion sort will work. Now here I will take one array which consists of 8 elements, 9, 2, 7, 5, 1, 4, 3, 6. Now we consider from the given element the first element as a sorted list. As I said, from the given list, what we have to consider, because insertion sort works on the sorted and unsorted list. Now we have only one list, so what we have to do, we have to consider the first element as our sorted list and remaining elements as a unsorted list. Now we select the first element from our unsorted list. The first element of the unsorted list is nothing but a 2, and we compare it with our sorted list element to insert that element at their proper position. Okay, so we compare whether 2 is greater than 9. We compare whether 9 is greater than 2. Yes, 9 is greater than 2. That means we need to shift 9 to the one position to the right. So what we have to do, we take store this value into some temporary variable and then move the 9 to the position of the 2, and then we have to take the 2 at the position of the 9. So in this way we have to shift the element, that is 9 at the second position and 2 at the 9th position. So we get now 2 elements in a sorted order. Our sorted list is get increased, whereas unsorted list is reduced. As soon as we have to perform all the comparison, our unsorted list is reduced, whereas sorted list get increased. Now we have 2 elements, whatever shown in the yellow colors as a sorted list, and remaining are the unsorted list. Now we pick up the next element from the unsorted list, which is nothing but a 7. We compare this element with each and every element of our sorted list. So we compare first 7 with a 9. So 9 is greater than 7. So we compare the next element with a 7, whether that is greater than the 7. No, 2 is not greater than 7. That means we need to shift only 9 to the one position ahead. So we shift 9 to the at the place of 7 and take the 7 at the place of 9. So we insert 7 after 2 and before 9. So in this way we will get now 3 elements in a sorted list, and there are only 5 elements remain in a unsorted list. As soon as we have insert the element from unsorted list to the sorted list, the size of the sorted list is get increased, whereas the size of the unsorted list is reduced. Now we pick up the second element from the unsorted list, next element, that is nothing but a 5. Now we compare this 5 with every element of our sorted list. So we compare first 5 with a 9. 5 is smaller than 9. So we compare with the second element. Again 5 is smaller than 7. So we compare with the next. Now 5 is greater than 2. So we have to insert 5 after 2. So we need to shift 7 and 9 one position right. Here we are shifting 7 and 9. 9 is shifting at the 5th position and 7 is shifted at the 9th position, and then we insert this 5th at the 7th position, that is after 2. Understood? So here we are inserting 5 before 7 and 9, whereas after the 2. So this is the correct insertion position for the element 5. So in this way we are inserting the element. So now we have a 4 element in a sorted list, whereas 4 element in a unsorted list. Okay. So now we take the next element from the unsorted list, that is nothing but a 1. So we have to find out where we have to insert this element in our sorted list. So we need to compare this one with each and every element of our sorted list. So firstly we compare 1 with the 9. Now 9 is greater than 1. So we need to compare it with the next element. Now 7 is greater than again 1. So we need to shift 7 one position right. Then we compare 5 with 1. 5 is also greater than 1. So we shift 5 to the 1 position right. Then we compare 2 with 1. So 2 is also greater than 1. So we need to shift 2 at 1 position right. So we shift 2 at here. Now this is the actual place where we need to insert the 1. So we insert the 1 at this position, that is before 2, 5, 7 and 9. So in this way we are inserting the element from the unsorted list into the sorted list. Now our sorted list contains 5 elements which are shown in the yellow color. They are at their proper position, whereas our unsorted list contain only 3 elements. As soon as we insert the element from unsorted list into the sorted list, our sorted list is increased. As here I shown, our sorted list get increased, whereas unsorted list is get reduced. So now we select the next element from the given list, which is nothing but a 4. So we need to find out the proper position, insertion position of this 4 into this sorted list. So we find out this insertion position by comparing this element with each and every element of our sorted list. So first we compare 4 with 9. Here we find out that 9 is greater than 4. So we move 9 one position to the right. Then we compare 7 with 4. Now 7 is also greater than 4. So we move 7 to the one position right. So 7 moves here. Okay. So then we compare next element, which is nothing but a 5. Now 5 is also greater than 4. So we move 5 to the one position right. That means here we are moving 5 here. Now we compare 2 with 4. Now 2 is smaller than 4. So we not moving the 2 to the right position because it is smaller than 4. So this is the actual place where we have to insert our 4. So we insert 4 after 2 and before 5. So in this way we get 6th element in their proper position, that is 1, 2, 4, 5, 7, 9. All the elements which are shown in a yellow color is nothing but our sorted list, whereas remaining elements are in our unsorted list. So we get 6 elements at their proper position and 2 elements from the unsorted list. We need to insert them in a sorted list at their proper position. So the next element is nothing but a 3. From the unsorted list we pick up the next element, which is a 3. Now we need to insert this 3 at the proper position in the sorted list. So we find out where we have to insert this 3. So we find the proper position of the 3 into the sorted list by comparing with each and every element of the sorted list. So first we compare 3 with the 9. Now 9 is greater than 3. So we move 9 one position to the right. So 9 is moved here, right? So then we compare the next element, that is 7. Now 7 is greater than 3. So we need to move 7 one position right. So 7 is moved to the right position, that is here. Then we check the next element, that is a 5. 5 is also greater than 3. So we need to move 5 to the right position, and here we are moving 5 to the right position. So then we check the next element, which is nothing but a 4. 4 is also greater than 3. So we need to move this 4 one position right. Shift that element one position right. So here we are shifting 4 to the right side by one position. Now we compare 2 with a 3. Now here 2 is smaller than 3. So there is no need of shifting. That means this is the proper position where we have to insert our element 3, right? So we have to insert element 3 after 2 and before 4. So in this way we get the 7 element in our sorted list at their proper position, whereas there is only 1 elements remain in the unsorted list, which we have to insert at their proper position into the sorted list. So we have to select the next element, that is nothing but a 6. Now we have to insert this element into our sorted list at their proper position by comparing and shifting. So first we compare this element 6 with 9. Now 9 is greater than 6. So we move this 9 one position right. We are shifting the 9 one position right. So here we are shifting the 9 at one position right. Then we compare 7 with 6. Now this 7 is also greater than 6. So we need to shift this 7 one position to the right. So here we are shifting 7 to the right position. Then we check the next element, that is a 5, and compare 5 with the 6. Now 5 is smaller than 6. So this is the right position where we have to insert our element 6, that is after 5 and before 6. So we have to insert this element after the fifth 5 element and before the 7. Okay, so this is the right position of inserting the element 6. So in this way all the elements are get sorted. So actual way of working of our insertion sort is nothing but a select the element from unsorted list, compare that element with the elements of the sorted list, and if we found that the element of our sorted list is greater than the unsorted list, then we have to shift. That means we have to shift the element of sorted list one position right, so that we can make the place for the element of the unsorted list. And then after shifting the element from the sorted list one position ahead, we can insert the element from the unsorted list into the sorted list at their position. Here I am showing how we'll shifting. Again we are taking one example. Here 5 is greater than 2, so we are taking the second element at their proper position, and 5 is shifting to the second position. In this way, if you look at here, one is from the unsorted list. We need to place the this one at the proper position. So what we have to do, we need to shift all the elements of the sorted list one position ahead, and then one is moving to the proper position. In this way, how this insertion sort works: by selecting the element from the unsorted list, then compare it with the sorted elements. If necessary, you need to shift the element of the sorted list one position right, and then insert the element which you have selected from the unsorted list into the sorted list at their proper position. So the time complexity that is required by our insertion sort is nothing but O of n square. Either it is a worst case or it is a best case, because it need to perform that many shifting as well as the comparison in each and every pass. So the actual time complexity that is required by our insertion sort is nothing but O of n square. I hope this insertion sort concept is clear to you. Thank you.